Hey peeps, I hope you have went through the first video. In this class, we will learn about a new topic which is thermal voltage, or it's also called the volt equivalent of temperature. So let's say that I have some energy. Yeah. So to create this amount of energy, there are multiple methods. And let's say I am considering two methods. One is by applying temperature, one is by applying voltage. So if I apply temperature, then the energy associated is given by K times T, where K is called the Boltzmann's constant. Boltzmann constant. So the value is given by 1.34 into 10 power minus 23 joules per Kelvin. And T is actually your temperature in Kelvin. T is temperature in Kelvin. Similarly, instead of applying temperature, if I apply a voltage across a given charge Q, then the energy associated with that charge Q is given by Q times the applied voltage, let's say V. So let's say that the temperature and voltage generates the same amount of energy. So the temperature generates some energy and voltage generates the same energy. So what is the energy by temperature, which is Kt, and the energy of voltage is Qv. Since they both produce the same energy, I can write Kt is equal to Qv is equal to that particular energy. So what does this relationship actually give you? Let's say that temperature variation occurs. So as a result of which a voltage can be assumed to be generated. Right. So temperature is a physical quantity and you know that voltage is an electrical quantity. So you can quantify the variations of temperature as a measure of voltage. Right. So from this expression, I can, let's say I write this V as Vt to show that the voltage is the voltage generated due to this temperature T when I equate this expression, right? So Kt is equal to Q times Vt. Now let's say that K is 1.34 into 10 power minus 23 and Q is 1 electron, let's say. So if I assume this Q to be 1 electron, then the equation becomes Kt is equal to E times Vt, and you know the value of E is 1.6 into 10 power minus 19 coulombs. So I can write Kt by E is nothing but my Vt. So I can substitute the values. So K is nothing but 1.34 into 10 power minus 23 by E is 1.6 into 10 power minus 19 and times E. Now this is my Vt. Now if I simplify this expression, I'll get, uh, yeah, this is not E, this is T, maybe a mistake. Okay. Now if I simplify this expression, I'll get T by 11600 is nothing but Vt. So from this expression, you can see that temperature and voltage are linearly related because you get a linear equation, right? So if temperature increases, voltage increases linearly. Now, moving further, we know that Kt by Q is then my Vt. Why? Because I just took this to this side. So Kt by Q is Vt. So from this expression, Kt by Q is equal to Vt, I can again say my voltage generated is this. So this expression is very much essential. Now moving further, I can go back and say KT is equal to Q times VT anytime I want. So basically I am quantifying this energy since K and T are in SI units. So this answer will come out in joules. Correct? And let's say that I have used one electron. So I can write E times VT. Now say I apply 1 volt to an electron. Then definitely I can say that KT is equal to E times VT, just like what we said before. Now, the energy associated with, okay, so this is basically a definition, okay. So this is a definition. So definition says, or let's call the energy of one electron at 1 volt. Now this is defined as electron volt. Okay. So uh, yeah, if I put Vt to be 1, right? So then I can say Kt is equal to E, and this is defined to be an electron volt. Why? Because I have applied 1 volt to 1 electron. So this expression will give me my electron volt. And definitely you can say that this value is in joule. Okay. And this value is 1.6 into 10 power minus 19 coulombs. Right. So I can say that, so I can very clearly say that 1 electron volt is nothing but 1.6 into 10 power minus 19 joules. Okay, actually this is not coulomb. This will be joule. Why joule? Because I have actually multiplied, right? So this unit is same as this unit. I hope that's clear. So this is the expression which I want you to understand. So 1 electron volt is nothing but E joules. 1 electron volt is nothing but E joules. Right. Now having said that, let's move further. Let's say that I apply some K volt. So 1 electron volt is E joules. Right. So from the previous expression, I can see that KT is E times VT, right? KT is E times VT to an electron. So what does that mean? So if I apply 1 volt, this is an electron volt. Now if I apply 2 volt, it will be 2 electron volt. So if I apply VT volt, so if I apply, let's say, K, so why did I replace VT with K? Because I applied K volt, right? VT was voltage, right? So here it's this voltage is K. So if okay, I'll use a better term. Let's say N volt. Okay, so that this K is not confused with this K. So if I apply N volt, right? If I apply N volt, that will be N electron volt. This is nothing but N electron volt. So the key takeaway here is that if I am given with some voltage V, okay, if I am given with some voltage V, then the corresponding energy is V electron volt. Okay, for example, let's say that I apply 40 volt to an electron, then the energy of that electron is nothing but 40 electron volt, right? So this gives a clear connection between voltage and the energy of the electron. Now similarly, if I apply 20 millivolt to an electron, then the energy is nothing but 20 milli electron volt, and so on. So this gives a clear connection between a voltage and energy, and also we have seen how a temperature is related to the voltage. So that's all for this particular video. See you all in the next video.